Hello everyone, this is Junaid here from Edureka and I welcome you all to this interesting session where we'll be looking into machine learning pipeline. So without any further ado, let's take a look into today's agenda. We'll start this session by discussing what is machine learning and why do we need it. Following that, I'll be walking you through the various stages while taking a machine learning problem set. Finally, we'll end this session by implementing machine learning pipeline on a real-time program. Before we begin, do consider subscribing to our YouTube channel to stay updated on trending technologies. And also, if you're looking for online training certification in machine learning, check out the link given in the description box below. I'm sure you now have a lot of questions like what is machine learning, why machine learning, if machine learning is all about decision making, why create a complex algorithm when I can work easily with if-else condition? Well, let's take a look at each of these scenarios. So starting off with why machine learning, right? Well, to understand this, I would say look into your day-to-day activities. What I'm trying to say here is if you're trying to find out an object, say a pen or a cell phone, you identify it by its characteristics like shape, weight, looks, and how it works, and many more other parameters. Okay, this gives rise to an interesting question. Did you know about all of these objects the moment you were born? Absolutely no. You were initially trained, that is, you were shown that this particular object is a cell phone or this particular object is a pen or a pencil. Then more and more you used, your perception about that specific object evolved as you started grasping various features about it. And now, given at any point of time, identifying an object is a piece of cake for you. Now imagine if this operation was to be achieved by a machine. It would be amazing, right? Well, this is exactly what happens in machine learning. Here we feed an algorithm with relevant data, or which can say features, which perform a task that is assigned to it. So now to answer the question, why can't I use if-else statement here? It's very simple. If-else statement on a large data set is computationally very expensive. So let us move ahead and see what exactly is machine learning. Well, machine learning is a type of artificial intelligence that allows software application to become more accurate at predicting outcomes without being explicitly programmed to do so. Here explicitly refers to if-else condition. Machine learning algorithms use historical data as an input to predict new output values. So what I'm trying to say over here is we have to provide historical data. Historical data over here refers to the previous data or a data set from a previous experience. And based on this previous experience, it creates a model. Well, machine learning is a type of artificial intelligence that allows software application to become more accurate at predicting the outcomes. So without being explicitly programmed to do so. Here explicitly programmed refers to having if-else condition. You see, machine learning algorithm makes use of historical data as an input and predicts new output values. Some of the best examples here can be recommendation engines. Recommendation engines are a common use case of machine learning. Other popular use cases can be like fraud detection, spam filtering, malware detection, threat detection, and many more. So now why is machine learning important? Well, you see, machine learning is important because it gives enterprise a view of trends to its customer behavior, business operation parameters, as well as supports the development of new products. Many of today's leading companies such as Facebook, Google, and Uber make machine learning as a central part of their operations. Machine learning has become a significant competitive differential for many companies. Coming down to what are the different types of machine learning, right? Well, speaking about classical machine learning, it often categorized by how an algorithm learns to become more accurate in its prediction. There are three basic approaches towards it: supervised learning, unsupervised learning, and reinforcement learning. The type of algorithm we choose depends on what type of data we want to predict. Starting off with supervised learning. In this type of machine learning, we supply algorithm with labeled training data and define the variables that we want algorithm to assess for correlations. Both input and output of an algorithm is specified. Then we have unsupervised learning. This type of machine learning involves algorithms that train on unlabeled dataset. The algorithm scans throughout the data and looks for common meaningful connections. Finally, coming down to reinforcement learning. We typically use reinforcement learning to teach a machine to complete a multi-step process for which there are clear defined rules. We program an algorithm to complete a task, give it positive or negative clues as it works out how to complete a task. But for most part, machine learning algorithm decides on its own. Now that you know what we are talking about, let me quickly walk you through machine learning pipeline. You see, we have 5 typical steps that we follow every time we take up a machine learning task. Starting off with data acquisition. Here it's all about collection of our data. Then whatever the raw data that we have collected, it obviously has to be cleaned, right? That's where we have the next stage, that is cleaning our data, or also referred to as data cleaning. And once the data has been cleaned, we have to visualize or find a relationship between the data parameters. Therefore, we use something called as EDA, which is a shorthand term for exploratory data analysis. And once we have all the raw materials, that is the data, which is suitable for predicting, or that is suitable for creating a model, or which is suitable for working on, right? Then we train a model. And then finally, once we have trained a model, we try to find out the predictions out of it. And if you're someone who's working on a real-time project, you'll be deploying that particular model on a web. So let's now see each of these steps in detail. Starting off with data collection. Data collection is the process of gathering and measuring information from countless different sources. In order to use the data we collect to develop practical AI or machine learning solutions, it must be collected and stored in a form which makes sense for a business problem at hand. So what I'm trying to say here is, we obviously need to collect data from various other sources. And in order for you to use this particular data in a machine learning or an AI model, you have to save this in a form which is suitable for machine learning to understand. And most of the time we save this in the form of a CSV file. In order to scrap the data from the website, we use some of the libraries such as Scrappy, Beautiful Soap, and many more. Alright, so next we have data cleaning. Data cleaning is a process of fixing or removing incorrect, corrupt, incorrectly formatted, duplicate, or incomplete data within our dataset. You see, when combining multiple datasets from multiple sources, there are many opportunities for data to get duplicated or mishandled. If the data is incorrect, output of an algorithm can be unreliable, even though they may look correct. There is no one particular way to perform data cleaning. What I would like to personally do over here is use pandas library to find out the null values and also see, if we have a missing values, fill them out with the mean of that particular column. Then moving on to the next one, that is exploratory data analysis. You see, exploratory data analysis is an approach for analyzing data set by summarizing their main characteristics, often using statistical graph and other data visualization methods. Statistical model can be used for seeing what the data can tell us beyond the formal modeling or hypothesis testing. And few of the popular examples or few of the popular tools for exploratory data analysis can be Seaborn, Matplotlib, Plotly. And these are popular Python libraries for EDA using Python. Moving on to the next stage, that is training a model. You see, training a model is nothing but providing a labeled data set to a particular machine learning algorithm. Most of the time we have the maths that runs behind, but the moment you're working on a real-time project or when you're working for an industry, you will not be hard coding that particular algorithm. Over here you'll be using a couple of built-in libraries such as from Keras or sklearn or even TensorFlow, and we basically feed data in the form of an array. And to use this array we use something called as NumPy. Okay, the agenda behind model training is to create a model, and model is something based on which we predict new values. Finally, on our last stage, we have prediction and deployment of a model. Prediction, as it says, we provide a new data to a model, and this particular model will give us an accurate result for it. So for example, if we have to perform a classification between cat and dog, we provide an image about a cat or a dog to a model. And model, based on its historical data and whatever the probabilities it has come out with, it will detect whether the particular image is of a cat or a dog. And finally, once you have created a model and you have tested on its predictions, what you would like to do is you would like to deploy it on a web. Obviously, we want a model or a product to be used by many other people. So for deployment, we basically convert whatever data we have into a RESTful service and deploy it using a Heroku or a Google Cloud Platform or AWS or various other cloud platforms. So now that we know what are the various steps that go in for developing a model, let me quickly walk you through a demo wherein we'll be taking a data set and then we'll see how we can perform EDA on it. So for this, let me quickly jump to my code editor. The code editor that I'm going to use over here is going to be a Google Colab. And let me import a CSV file. Here I won't be demonstrating to you how to scrap a website. Okay, I'll quickly import a data set from my system over here. So you can upload your data set from here. Okay, so as you can see here, I have imported my dataset over here. And now all we need to do is we need to get this dataset into our model over here. All right. So if you remember, the type of dataset that I'm using over here is for a Titanic dataset. It is a pretty popular dataset when you're kind of working out, if you're a newbie and working out around machine learning. Okay. Now, the first stage over here is data collection. We have already collected our data. We can either scrap this from website, or you can, sometimes the data set is readily available on websites like Kaggle or something. We can download the CSV file and use it. So the first step over here is I need to import a couple of libraries, that is import pandas as PD, and I'll also import NumPy. Okay, and let me execute this. Now we have to read this particular CSV file. Okay, I would give this as train. This would be equal to, if you want to read a CSV file, all we do is pandas.read CSV. And once you have this, you just need to pass the value of this path. So we'll copy the path and pass it over here. Okay, and let's kind of visualize how this data would look like. We can do this, or let's do train.head. Okay, so if you can see here, we have a couple of classes, and over here we have to decide like what is an output value here, or the value of y. Okay, so this thing over here is gonna be like the output. Here we are trying to serve, as is a Titanic data set, we are trying to perform a classification here. We either want to find out whether a person has survived or he is dead. So 0 over here refers to person did not survive, and 1 refers to person has survived. Okay, and this nan over here refers to the empty values. Okay, and these p classes, survived, name, sex, age, and all of these are nothing but the data or the features for this data set. All right, and let's quickly see the shape for this. Okay, and you can see here we have 109 rows and 14 number of features or columns. So now our first stage is done. We try to get our data. Okay, that is, let me quickly comment it down here for you guys. Data collection. Fine. And now in our next stage, what I'm going to do is we need to clean our data. Okay, so now in order to see, or in order to clean our data, what I would do is I need to know the information about this. So to get that, so train.info. So this would basically give me how many nan values we have, how many missing data we have, and all that. So you see, we know that we have total number of data is 109. Okay, and if you can see age, we have quite a number of missing data here. But if you see the cabin, right, cabin, boat, body, and home destination here, there's a lot of data set that is missing, more than 50%. So what I'm going to do is I'm going to drop this data. Okay, so in order to drop the data, all I'm going to do is train. Train is basically the name of our data frame. Data frame is this particular table that we have here. Okay, so what I'm going to do is train.drop. Okay, and I'm going to pass labels, and here I'm going to basically pass the list. So I don't need the body. Okay, apart from that boat. The reason is because there's a huge amount of missing values, right? And then we, all the same time, we don't need home destination, then even the cabin. Let me put this within the quotes. Okay, so this would drop all of these, and apart from that we have two more parameters, that is the access. Access by default is 0. 0 means it would remove that data in that particular row, but we want the entire column to be removed, so we'll change that to 1 in order to update this particular training data frame, right? Either we can just equate this to this, or we can use another parameter called as in place, and if I just put it as true, and if I give train.shape, okay, so you can see here we have dropped 4, right? Before there was 14 number of columns, now we have 10 columns. Okay, this is not the end of our EDA. Apart from that, we also want to drop couple more things. So let me again write train.info. In this stage, what I did was I dropped the data which has, okay, the reason why I'm getting this error is because we have already dropped it. So let me rerun this from start here. All right. So now what I'm going to do is, like right now, I just removed these 4 columns, right? Because we had huge amount of missing data. But apart from this, I also want to remove couple more data. That's because, you know, it's like, for example, you see fair. Fair is basically, if you look into the data set. So let's print our data set again. It will be train.head. If I look into the fare or how much the person has paid, it is irrelevant, right? So it doesn't matter what fare he paid when I have to judge whether a person survived or not. Similarly, even the name over here doesn't matter. All right, and sex does matter, how many number of male and female. Age does matter. Okay, and we can also remove this PRs and embark. Okay, so let me quickly get that done for you guys. So train dot drop, and here we are going to pass labels, and within this label, list of things that we don't need. We obviously don't need the name, because name as a parameter is not going to help me out like in finding whether, you know, a person has survived or not. Then we also have ticket, and again we don't need embark. Okay, and similar to earlier, we also have to give access is equal to 1, and then apart from that we also need in place is equal to 2. and let's execute this. Okay, so we have dropped the data over here, and now if you have to see what our data would look like, train dot head. Okay, these are the things that goes in for decision making. Now coming down to creating our label data. Okay, so here we basically will have x and y, right? So x is nothing but the input parameters. So I'll give it as x test or x train because it's a training data set, and then we'll also have y. Y train is all about this predicting the outcome of this, right? So it's basically like whether a person has survived or not. Okay, and all that. But before that, what I'm going to do is we have to fill out this nan values, right? So we have to fill the empty sets. So let's kind of fill that. So what I'm going to do is train, which is our data set. And if you can see, we have a lot of nan values for age, right? So I'm going to do that. Then it'll be train of age, and I'm going to take the mean. Okay, before I take the mean, I cannot take the mean as of now because we have NA. So I'll just first off fill it with NA. Okay, and it will be like fill the places wherever we have nan values with zeros. Okay, and now if I just hit train, right, you'll see the age we won't have nan values, we'll have zeros wherever there is that particular value is missing. Okay, now I'm gonna take the average of it or the mean. So m is equal to np dot mean of which value, that is train for it's gonna be for age. Okay, and now what I'm gonna do is I'm gonna perform a replacement, that is train of age. All right, so this would be equal to train of age dot replace. Wherever I have zeros, I'll be replacing it by mean of that value, and let me hit enter. So now let's see what this would look like. So as you can see here, the average or the mean age is coming down to 24. So I have just put on that particular value. So it's no more zero now. Okay, fine. So now what I'm going to do is I'll use train.info. So let's see what are the other values that we are missing. All right. So as you can see over here that we have 1009 values, and only place where one more value is missing, that is fair. Okay. So we'll fill that up. So what I'll do is I'll do train of fair. That is, I'm trying to select the column, fair column. All right. So here what I'll do is train fair dot fill NA, and wherever there is NA, I want to fill it by the mean value. So it will be np dot mean. Here I'll pass train of fair. Okay, and let me execute this, and let's see train dot info once again. All right, so as you can see over here that we have no missing data anymore. Okay, we have filled even the fair, the one value that was missing out. So now let's kind of see how does train looks like. So as you can see, now only thing that is left is to divide our data. So over here, like the survived part is going to be our y. Okay, y is basically the output, whether the person has survived or not. And the other are the features over here, which gives us, whether a person, what is the probability that person might survive or not. So each of these features is like equally responsible for giving out a prediction. So now what I'm going to do is, this is still the part of feature selection. Okay, that is the second stage. Okay, but one more step we have to do before that is we have to label encode this sex column. Okay, so we have male and female, right? So we have to do the label encoding. So for this, let me just give a comment here, label encoding. So what I'm going to do is train. Okay, first off, we need to import the library from sklearn dot model selection, import train test, import label encoder. It's not from model selection, it's pre-processing, import label encoder. All right, that's great. So now what I'm going to do is wherever I have the sex, right? So I want to label encode it. So I'll give LE is equal to label encoder. Okay. And now for this LE, I'm going to use fit transform, LE dot fit underscore transform. Okay. And here all I need to do is provide the data, that is train, and the column name is sex. Okay. And let's execute this. And now if I just put train dot head. Okay, so you can see the data over here has been label encoded, and the female is represented by 0 and male is represented by 1. Okay, so now moving on to the next stage, that is model training. So as you can see, the huge amount of time takes in when we are trying to extract the features. Okay, data collection is pretty simple. but cleaning the data or whatever you have processing the raw data is pretty tough. Okay, it's not tough, it's just that we have to look into various parameters over here. All right, so let me quickly write here model training. So for model training, what I'm going to do is, first off, we need to take out the x and y value. So y refers to the output, right? And x refers to the parameters. So I'll give here x train. So x train over here will be train dot loc. Now I need all the rows, and except the survived column, I need the rest of it, right? So what I'm going to do is train dot column. This thing gives me the list of column names there, and we don't want this to be equal to survived. Okay, and similarly for y train, I need train dot loc, and we need it for all the rows and only for the survived column. And we don't want this in the form of a data frame, so I'll give here as values. And similarly, we'll do it for x as well. Okay, so the place where I went wrong is here. So this is gonna be first, right? So yeah. And now if you want to see how x train would look like, this is gonna be uppercase here, and let's see. Okay, so now it's in the form of an array, right? So this first array is the first column. The first array here is the first row. Second array is the second row, and so on and so forth. And similarly, if you want to see y train, so this is basically giving me the output, that is 0, 1, 2, 3, and so on and so forth. So now what I'm going to do is I'm going to put this model or whatever we have gathered the data into a model. So what I'm going to do now is from sklearn dot tree import. Let's see what are the things that we can import. So you can see a basic decision tree classifier, decision tree regressor. As we are trying to perform classification problem here, I'm just going to import decision tree classifier. Okay, and if I execute this, first off, I'll be creating the object of our decision tree. So DTC, that is decision tree classifier, is equal to decision tree classifier. Okay, and these are the various criteria that we can take here. We can take Gini impurity or entropy. Then splitter, we can take best, or we can take random. Then we can also define here max depth. Max depth is nothing but the length of the tree, and minimum sample split by default it's given to minimum sample leaf is 1. All of this is nothing but fine tuning our parameter, our machine learning model. I will do that in a while. So first off, let me just keep a default settings. Okay, and now what we'll do is to train a model will be DTC dot fit, and now all I'm going to do is pass x train and y train. Okay, and let me execute this. And now if I want to predict any values, right, so it will be DTC dot predict. All I need to do is give the value of x. Okay, and now over here I have the test data set. So similarly, what you did for the training data set, you have to pre-process similarly for test data set. Instead of doing that, what I'm going to do is I'm going to create train test split here. So that is from sklearn dot model selection import train test split. Okay, and now what I'm going to do is train test split. Okay, so what I'm going to do, let me copy this train test split and let me paste it over here. This would give me x train and x test values. If you look into this documentation, right, you actually don't have to write everything here. You can just copy paste it from the documentation. If you want this in a better way, you can just put question mark and execute this, and you get a documentation here on the left hand side. And now all you need to do is just copy this and paste it over here. All right, and let me quickly get rid of this, and this over here, it will be x train and this will be y train. All right, as the data set is small, I will not keep 20/30, I'll keep 20 and 80. That is 80% goes for training and 20% goes for the testing. And let me execute this. Let me rerun all of this again. Okay, now what I'm going to do is instead of train, I'll pass test value. Okay, we're trying to predict. Okay, so this is the fourth stage over here. Okay, here we are trying to predict the values. So if I put here x test, we over here, as you can see, we have predicted the values of y. So if I give here as y pred, all right, so as you can see, I'm just passing the X values and the Y parade is nothing but the predictions. Let's now see how well our model is performing. In order to do that, I can just learn, like I can import a matrix. So from sklearn dot matrix import, you can use accuracy score and hit enter. So now let's see accuracy score, and the parameter is Y true and Y parade. So Y true over here is going to be Y test, and Y true or Y parade is going to be Y parade itself. Okay, and now let me execute this. So you can see we are getting its accuracy as 75%. Now we can better increase this accuracy by changing the values of our hyperparameter of our decision tree. Let me quickly show you how I can do that. Okay, so here what is happening is basically our model is trying to overfit. Okay, and in order for me to prevent that up, what I'll do is I'll change the max depth. Instead of max depth to be like infinite, I'll give it as 6. Then we also have minimum sample split, that is minimum samples in a split. I'll give it as like 5. And then let's see a couple of more. Okay, splitter is the best, so we will not change that. And minimum impurity increase, that is minimum impurity decrease over here. So let's give 0.01. So if you can see here, the previously our model was predicting somewhere like 75%. Let's see how much it would be after hyperparameter tuning. So as you can see here, we have increased our accuracy score, and this can further be increased by using random forest. Okay, and this is how we can actually predict your model. You can provide individual data and get a prediction out of it. So once all of this is done, you can use Heroku or you can use Google Cloud Platform or Azure to deploy a model so that it can be available for public. Alright guys, with this we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in a comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!